Okay, so I'm going to just do quickly the example from the book, 15.18. There's a mistake in the book now, so this is for using the trapezoidal rule, but it says to do it between 1 and 4, and then it goes 1 and 2, and it does the whole calculation with 1 and 2, so that's a mistake. So I'm going to do it now instead with 4 here. So we're going to just look at the log tables, and we're going to copy out the formula, and then we'll work with that. So it's page 12 in the log tables, trapezoidal rule formula. So you can see here the h value in the formula is going to be the distance between each of the trapezoids. How do we get that distance h? Now you can kind of assume in a question that the trapezoids are going to be of equal width, all of them. That's just the way the question will be set up. So I know this one's quite easy. We can see straight away it's going to be 1, the width of the trapezoid. But if you don't know, if it's not as straightforward as that, what you do is you pick the last value of x. So that would be 4 in this one. So the last value of x, you take away the first value of x, so that would be 1, and you divide by the number of trapezoids there are, so that's 1, 2, 3, there's 3 trapezoids inside, so 3, so we can see then 3 over 3, which is 1. So our h value here is 1. Next then, see the way it goes from y1 to yn. What does yn mean? So yn basically means the last line of the formula, the last line of the curve that we want to get the area under. So in that case, this would be yn here, but it's not like n means anything. N is just the last term. So we can see that this would be y1, the first one, y2, y3, y4. So yn is equal to y4 in this one. So that means n is equal to 4, basically. So one by one, we're going to get y1, y2, y3, and y4. They're all the ones we need for this. y1 is going to be e to the 2x when x is equal to 1. So that will be y1 will be e to the 2 times 1, which is just e to the 2. Likewise, e2 will be e to the 2 times 2, which is e4. And same, sorry, I wrote that wrong. e4, and then same for the others. This will be e6, 2 times 3, and this will be e8. So they are our 4, y1, y2, y3, y4. And we're going to now, with h, we're going to fill all these into our formula to get the estimation for the area. So the area here will be h over 2, so that's 1 over 2, y1, e2, plus y4, e8, because yn is y4, remember we said, plus 2 times, so we only have to do the ones that aren't included in the 2 here. Y1 and y4 are included, so all we need to include in the brackets is y2 and y3, so that will be e to the 4 and e to the 6. So that is our total formula filled in, and you'll see I just did the y1, y4, y2, y3 just on top just to show they all match up. So if we type all this in the calculator, we'll get the estimation for the area as 1952.2. So that is our estimation using the trapezoidal rule. Now we're going to get the area using integration and see how that differs to that. So like we did before, this is part 2, so definite integral. So we have 1, 4 as our bounds, e to the 2x dx. So we're going to integrate this as per usual. The integral of e to the 2x will be e to the 2x over the derivative of the power, so 2, 4, 1, so we end up with e to the 8 over 2 minus e to the 2 over 2. So our area is actually, that will give us 1486.8. So you'll see it's actually quite a big difference between the actual area and the estimation area. And you'll see that the trapezoidal rule area is actually bigger than this. So the percentage error, all you're doing is taking 1486 from 1592.2 will give us 465.4. And then, so the percentage error is going to be this over the actual area, which we know is from integration, so this here. So our percentage error is 31.3%, so it's a massive error, and obviously the trapezoidal rule is bigger than it overestimates the area. But for the last part, we can't just say that. We have to prove why it is. So we would say trap rule overestimates. And what was the reason we said in the last video? The curve is because curve is concave up from the diagram. You can kind of see it's concave up, but we need to show it is. So how do you show it is? We will get dy dx first, which will be e to the 2x over 2. Sorry, e to the 2x times 2, because it's chain rule, we're differentiating. And then the second derivative will be e to the 2x times 2 times 2. So that's 4e to the 2x. And because this is a power, there's no way this could be a negative number, so we know this is going to be greater than 0 for the whole time it's on the curve here. So that means it is concave up. The second derivative is greater than 0, so it's concave up, which means it overestimates. That's our kind of proof that it overestimates. So that is how you do that question. You should now be able to attempt the questions in the book 13, 14, 15, which are on trapezoidal rule, and just make sure you follow the rules for the concave up, concave down, etc. at the end.